Good morning, pilot teachers and students. Good morning, class.
Good morning, sir.
All right, thank you, Miss Sid. All right, firstly, I'd like to welcome you back to term 3. All right, we'll still continue with electricity from last term, and one of the topics that we will study this will be in relation to what we studied in last term, that is on resistance and cross-sectional area. All right, I will go through and then explain each one of these slides and also the notes, and then after that I will give you one or two questions to do as a backup of that work. So I will now go through and then looking at the cross-sectional area and resistance, you'll find that the resistance is inversely proportional to the cross-sectional area, meaning that if the resistance increases, what will happen to the cross-sectional area? It'll be less. Okay, it'll be less. So if you have a larger cross-sectional area, all right, the resistance will have to increase. And from this, the resistance of a wire depends on the cross-section, right? Meaning that the thinner the wire, the more resistance, and so the more wires we bundle together will give a wire in parallel, and this time it will have more resistance, right? In last term's lesson, you should have known something on, or you may have seen something on the resistors which are in series and parallel. So when you have wires which are connected end to end, resistance will have to increase. But when you have resistors or the wires which are put side by side, resistance will have to decrease. In other words, it is telling you that when you have wires that put side by side, you are increasing the area, and that means the resistance will have to decrease. So quickly go through. Pilot students, you can also go through, get your books out, your pencils or pen, write this or have this information down. I'll give you a few more slides and also the equation for resistance and cross-sectional area, and after that there will be some exercises. All right, just say, right, if you have wires connect side to or length, by length you will have 2R, meaning that resistance, but you find that the area is still small. Right, this area is quite small, that cross-sectional area is quite small, so that means resistance will be high. In here, putting that side by side, so that means you are increasing the area. So in here you have a larger area, and that is why resistance will be high, less. Okay, resistance will be less. Right, here is the next. All right, basically that means the resistance of a wire is inversely proportional to the cross-sectional area. So you are given by the equation as R equals to 1 over CSA for cross-sectional area. Are you finished? Okay, here is the next. All right. from last term's work, you should have seen that resistance is proportional to the length. So that means when length increases, resistance also increases. And our topic for today will be resistance and cross-sectional area. So combining that two, which is resistance is proportional to length and resistance is inversely proportional to the cross-sectional area. Right? Combining these two equations, we can get R is proportional to length over the area. Right, you have the insulators and also the conductors. Okay, conductors may be poor conductors, and then you have good conductors of electricity, and these are semiconductors. Right, looking at the resistivity, meaning that there is a certain property of that substance that will cause it or allow it to have effect on the resistance, and that is usually at the temperature or 0 degrees Celsius. Right? You know from our last lessons, resistance will always increase with temperature. So for this resistivity, it is for only at 0 degrees Celsius. Right, so quickly go through and then have this resistivity of these conductors, semiconductors and insulators, and then I will give you those questions. Right, in case you might be thinking what all of this stand for. Right, this is rho, a Greek letter for resistivity, and polythene, which is an insulator, has 10 to the minus 14. The unit will be in ohm meter. Okay, ohm meter. Also for the silicon, which is 10 to the minus 3, and then you have iron, which is almost about 8.9 times 10 to the minus 8, which is a conductor, and then you have copper, which is 1.6 times 10 to the minus 8 ohm meter. Now, because it has less resistivity, that is for copper, it is a conductor, but because it has less resistivity, or especially allowing that electricity to flow through, most of the wires that carry electricity are made of copper, or they are copper wires. Alright, this one should be minus 13. For semiconductors, the silicon should be 10 to the minus 13. That is the resistivity. You finish. Right, there are 4 questions. This is question number 1 and 2. Right, maybe I'll go through one example with you and then you can do the rest of the questions. There are 4 questions. All right, give me the length of a wire. Okay, let's say the wire is 1 meter. Okay, let's say the cross-sectional area will be let's say if it is 2 millimeters square, 4 will give you 10 ohms, and then 4 millimeter square. Okay, you are trying to find that what resistance will 4 millimeter give. Right. You can come up with the answer and then verify whether it is true, because you know that when you have a large cross-sectional area, resistance will be low or less. All right, that is simply by using ratio and proportion. If you have understood ratio and proportion, you can go through and solve this one quickly. All right, that is simply because resistance equals to 1 over CSA. So that is why we have 1 divided by 2 over 4 times 10 over. So if you have to solve this one, it will be 1 over 1 times 4 over 2 times over x. Okay, we can have this as 4x. That will be okay, 1 over 1 times 2 over 4 over 2. All right, we can have this one, which is equals to 20 equals to 4x, and then when you want to find this, it will be 4x 4, which is equals to 20 over 4. So the answer will be 5 ohms. So you can now see that that is 10 ohms. So the area, cross-sectional area, is 10 ohms, and then you have this one, which is 5. Okay, when you have a small cross-sectional area, resistance will be high. Okay, when you have a large cross-sectional area, the resistance will be low. All right, you can go through and then copy these questions. So pilot students, you can also copy the first 2 questions. I will give you the next 2, and then you can go through and then solve those 4 questions. If you have any difficulty in solving the question, you can raise your hands up. Where is your first one? Your first one? Or you are doing the first one? Okay. Okay, 1 divided by 2 over 4, so I get the inverse of that first equation. Okay, 1 divided by, yeah, so 1 over 1 divided by 2, and then I get the inverse 4 over 2 times, and then I,
it's 1 over 1 times 4
that's right,
times 10x.
that's right, that is because it is 1 meter, 1 over 2, 1 over 1.
So you cross inverse and cross multiply.
That's right. Okay, the first one is 1 over 1 divided by 2 over 4, and then you get the second, and then you get the inverse of that before over 2 when you multiply that. Okay. Yeah. Yeah. Maureen, question number 1. The question number 1. Let me see who is going to. Charlie. The question number 2. Question 2. You have any difficulty with that question? I'll help you to. If you have any difficulty with question number 2, okay, you can ask for help and then probably go out and write your answers and then you explain. Okay. Let me see. Which question are you willing to? I'll give you question number 3. Question 3. Okay, I'll show you. All right. This should be question number 3 and 4. Let me see. Question number 4. All right, for question number 4, you can use a table on resistivity and do that question. Okay, that is especially for this. All right, you know that copper wire has a certain resistivity, and then using that, you can put that into the equation, which is resistance equals to. Okay, you know what to do, so do that.
This one is in meters. This one is in meters, not millimeters.
Well, what resistance over length?
10 meters.
10 meters. Question 1, question 2, question 3, and question 4. Question 2. What is your answer? 1.6. No. Check. Okay. Let me use your pencil. So 2 over 1. 2 equals to 14. And then what would be 50? Let me see, is this correct when you have to? Okay, when I cross cancel this, 2 over 1 times x over 2 equals to 40 over 50. So it's 50x. When you see 1, 1. So when you have this one, 40 divided by 0.9. Let me code for the first. Okay, where do we go for the first? Let me see. How did you come up with the first 1.6? Okay, x over 2. Cross cancel out. You get the inverse of that because you have 2 micron y out. And then you get that. This one is the same, following the same. So did you follow this one to come up with that? And 2 over 1, yeah. Okay, so when you multiply, you have 2 millimeter x equals to 50. So 50 equals to x, and then you have 50x divided by 18. 2 millimeter, there is 2. Another 2 there. So when you get the inverse of that, this and this will cancel out.
Did I do this right?
Well,
Turn on 10 meter over 1 divided by, that's 1
1 meter equals to how many? Equals to 5. So 10 millimeters equals to x. And then what did you get? 10 over 1 times 10 over 1 times 5 over, okay, x. So 10x divided by 10. Yeah.
So I just cross multiply with 5. So then 5 into.
Okay, let's see. 10 over 1 times 10 over 1 times 5 on x. So it'll be cancel there. 10x is it? 10 times 10 will be 20. 100. Okay, 100 there. So there's 100x. 5 divided by 100 will be 0.05. What is it? Ohms, is it? Ohms? Yeah,
That's right.
that's right. Okay, when you are going through that question, question number 1, 2, and 3 should be using the same concept as question number 1, 2, and 3. Now for number 4, you will have to use the table to help you calculate the resistance, including the formula, and that is resistance equals to length over the area times permittivity. But for question 1, 2, and 3, you will only use ratio and proportion to come up with whatever resistance is for those lengths. Let me have a look at your question for the last. You said going through. Okay, because you are using all of this, maybe you can change into only one diameter. If it is a millimeter, change that to meters. You have 10 more minutes before we go through. One over the length over the area, that's right, times P. You will also use that constant. Yeah.
This one, that's the constant.
That's right. If you were using copper, then you look for the
Then we look for the
constant for the copper. All right, if you are using the last one, there will be resistance equals to okay. That is what you can use to come up with your all right, we will now go through the correction to question number 1, 2, and 3. Right, so as soon as the first person goes up, right, the others get ready. So question number 1 will be Maureen, question number 2 will be Jolene, 3 will be Joseph, and last one will be Solomon. Right, those students that I've just mentioned your name, you can come up and then show your working out and also your explanation. Right, question number 1.
Because when the area, cross-sectional area increases, the ohms, the resistance decreases, so it's inverse. Therefore, you have 2 on 4, and the inverse x on 20, and 4x equals to 2 times 20 is equals to 40, so 4x is equals to 40, and x equals to 10 ohm.
Right, 10 ohms for the first one. Right, that is the answer to the first question. Right, question number 2.
We are asked to find the CSA. So given that 2 millimeters squared is equals to a resistance of 40 ohms, then we cross multiply and you get x on 2 is equals to 50 on 40. Then you cross multiply 40 times 2 times 40, you get 80, and 50 times x, you get 50x, and then you divide 50 by 50x and 50 into 80, you get 1.6 square millimeters is equals to x.
Okay, we'll check through these answers later on. We'll have the third person to go and then okay, can you see the marker that is there?
As you can see from this, this is it's in inverse proportion. So I put this in a fraction form. 1 on 10 equals to x on 5. Cross multiply. No, sorry, not cross. I don't cross multiply. Multiply across 5 equals to 10x. Therefore, x is equals to 0.5 ohm.
We'll check the answers later. We'll have the last person to go through. That's right. You use pi r square for the area and length. Right, let's go through and then have a look at each one of these. Okay, all right, first one will be 10 ohms. Second one will be, if you just use ratio and proportion, all right, you will have to arrive with this answer. That means 2 millimeters will be 40 and 1.6 will be 50. But if you decide to use that with length, right, you will come up with 0.8 millimeters square. Okay, because resistance is proportional to length over the area. All right, looking at the third question, you have 50 ohms, and the last one will be 0.51 ohms. Okay, those are the answers. You can go through and then verify or check with your working out. Right, to quickly go through and then summarize what we went through in the lesson. Right, resistance is inversely proportional to the cross-sectional area. When you have a larger area, resistance will be less. If you have a small area, resistance will be high. But also it depends on the property of a conductor in which this electricity will pass through. Okay, that is known as resistivity, and it is given by a symbol. Now, resistivity for copper is quite small. That is why most of the conductors of electricity will be copper wires. Right, so that brings us to the end of the lesson. Right, pilot students, you can also go through and then check your answers with this one's given. All right, our keyword for key phrase would be resistance and cross-sectional area. Good morning, pilot teachers and students. Good morning, class. Good morning, sir. All right, thank you. Be seated.